Welcome to BeeGraphy. Learn how to create fort architecture using tools such as ellipse, linear arrays, scale, remap numbers, graph mapper, tween curve, and loft surface. You will be able to control the radius of the castle, the distance between the ellipses, their count, their scale change. By controlling the width and length, we can change the size and shape of the ellipse. Two range input nodes named Radius 1 and Radius 2. Let's control its dimensions. We will use the ellipse node as the base of our design and adjust its dimensions. The linear array node lets us copy the ellipse, forming a series of concentric rings stacked on top of each other. A vector z node will provide the direction for the array, guiding the ellipses upwards. Let's use a range input to define the overall height of our fort. We'll call it height. Let's use another range input to control the number of ellipses spread along the height. To distribute the ellipses evenly across the height, we will divide height over count to get the distance between two ellipses. Use the scale node to shape curved walls. You can scale them up or down based on a factor. The centroid node helps locate each ellipse center to measure them correctly. We'll use a graph mapper node. The graph mapper node lets you adjust how things change by using a simple curve. It's great for making transitions or custom shapes. This connects to the list sequence SEC node, which makes a series of values in order. It helps control how things change step by step. Next, we'll use the bounds node to get the minimum and maximum values from the graph mapper. These values go into the Remap Numbers node, which adjusts them to a new range, from 1 to the range input. This lets us scale the ellipses more precisely, creating a smoother curve for the fort walls. Here in a small part, we will show the power of Graph Mapper. Now we'll use the second scale node, so we can get a plane between those curves later. First, use the deconstruct point node centroid to get the coordinates of the node. Then, connect the x and z outputs to a construct point node. To change the y value, connect the y output of the deconstruct point node to the a input of an addition node and add some distance to it. We'll call that distance center shift. Next, we'll add another range input node to determine the scale size, and we will call it scale 2. The reverse list node is used to reverse the order of the list elements, which will allow us to make the topmost ellipses the priority. The list item node allows you to select the last curves, ellipses. Once these front curves are defined, we then apply the move node to move the front curve along the vector z direction. Then, to control that vector, we will of course use the range input node, giving it minimum and maximum values, and the name gap. Next, we use the tween curve node to create new curves between two existing ones. This helps make a transition between the moved ellipse and the others, giving a more natural shape. To control the transition, we need a sequence of values that determines their number and distance. For this, we will use the list sequence SEC node. And the list sequence SEC node will control the two range input we created. Again, we use the scale node, and of course connect it to the centroid node, as we already know. We use a second graph mapper node, just like the first, to control how the tween curve scales based on a graph. We'll use the bounds and remap numbers nodes to scale the output from the graph mapper. This lets us control the size of the tween curve accurately. As said before, here we will also add a range input node, naming it cap size 2. The pipe node turns our curves into 3D tubes. To adjust the thickness of the tubes, we'll use the range input node we created, and we will call him pipe radius. To create a smooth surface between the modified ellipses, we use the loft surface node. It connects the curves and forms a continuous surface, blending everything into one smooth 3D shape. The region difference node subtracts one shape from another. It takes two shapes and removes the area of the second from the first, creating a hole or empty space. This is helpful for cutting out parts. The curve to surface node turns a curve into a surface. It uses the curve as a boundary. The extrude surface node allows us to give thickness to our surface, making it a solid shape. In this case, we'll give it a thickness value in the vector z direction. The Apply Material node allows you to define the color, texture, roughness, metallicity, and opacity of our design. The Hide function is used to temporarily make objects or components invisible in your design. Now let's activate the demo from the menu to the right and see our model. Thanks for watching. We hope this tutorial helped. For more on computational design, please like this video, subscribe to our channel, and hit the bell icon to get the notifications. See you in the next tutorial.